Imagine being like 10 miles offshore, right?
Oh, yeah.
You're staring down this massive, bruised purple storm front that's just rolling in fast.
Terrifying.
Yeah, completely. And you reach for your high-end Cobra Marine radio. You hit the talk button to call the Coast Guard, and just absolute silence.
Nothing. Just the wind.
Exactly. Or, maybe you're deep in the backcountry, you're separated from your off-roading convoy, and all you get is this deafening hiss of static.
Yeah. That happens a lot more than people think.
It does. And so today we are mastering the intricate programming, the tuning, and the rigorous maintenance of Cobra radios. We're pulling from this incredibly detailed technical guide from Yacht Supply 24.
It's a great resource.
It really is. And our mission for this deep dive is to cut through the assumptions and really understand the raw physics of how these marine and land-based systems actually work. So, okay, let's unpack this. Because I think the prevailing assumption is that a premium radio is essentially just a rugged walkie-talkie.
Right.
You pay $300, you charge the battery, and you expect it to just magically punch a crystal clear signal through miles of dense forest or open ocean without a second thought.
And that is the single biggest trap users fall into.
Really? Just assuming it'll work out of the box.
Oh, absolutely. Because we are so conditioned by modern smartphones, right?
Sure.
And smartphones, they operate on these established billion-dollar cellular networks that are handling all the heavy lifting in the background. But a Cobra radio is a completely different beast.
It's standalone.
Exactly.
Yeah.
You are holding a raw, independent transmitter and receiver. It has to generate its own radio waves and physically force them out into whatever physical environment you happen to be standing in.
Right.
So if you treat that piece of hardware like a closed-loop consumer gadget and you just ignore the setup, you are effectively taking a high-performance engine and trying to run it while the air intake is taped shut.
Oh, wow.
Yeah. The physical tuning dictates whether you have a lifeline or, a highly durable paperweight.
A very expensive paperweight.
Exactly.
Well, and before we can even get to the tuning part, there is this fundamental choice in the hardware itself. Cobra basically divides its lineup into two distinct ecosystems, right? The CB and the GMRS.
Right.
And for an enthusiast audience, these acronyms aren't new, but the way Cobra specifically optimizes its hardware for these two totally different physical realities is striking. We aren't just talking about different buttons on the faceplate.
No, not at all. What's fascinating here is how the physical environment dictates the technology you actually choose. We're talking about vastly different approaches to physics.
Okay.
So CB, or Citizens Band, that operates down in the 27 megahertz range.
Which is pretty low, right?
Yes, very low. Those are massive, long wavelengths. And because the waves are so long, they can literally bend over hills.
Wait, they bend?
Yeah, they bend over the terrain and they punch right through dense foliage. That makes CB the absolute standard for long-range, land-based communication. It is basically a brute force tool for distance.
Okay, so if I'm thinking about this visually, a CB radio is kind of like a long, steady cross-country highway.
I like that, yeah.
It's built to just go the distance, get you over the mountains, straight path.
Exactly.
But then you have GMRS, the General Mobile Radio Service.
Right, and that operates way up in the UHF band, around 462 megahertz.
So much higher.
Much higher. So those waves are much shorter and tighter. They rely heavily on line of sight.
Like they need to see where they're going.
Sort of, yeah. They bounce off buildings. They don't penetrate dense forests nearly as well. But because that frequency band is much wider, GMRS can carry a lot more complex data.
Oh, okay. So sticking with my analogy, if CB is the cross-country highway, GMRS is more like a really wide, multi-lane neighborhood street.
Yes.
It's shorter, it doesn't go across the country, but it allows for a lot more complex traffic.
That's a perfect way to put it.
Which totally explains why the Cobra Microtalk series and their other GMRS models are loaded with all those specific environmental features.
Right, the extra data bandwidth.
Yeah, you get the NOAA, emergency weather alerts, the advanced noise reduction algorithms, the complex sub-channels. The hardware is basically leveraging that wider UHF band to process a much denser stream of localized info.
Exactly. It's built for rapid coordination in a really dynamic environment.
Yeah.
Whereas the CB is just trying to get your voice over that next mountain range.
Got it. Okay, so assuming you have selected the proper RF tool for your specific environment, the Yacht Supply 24 guide gets incredibly particular about the very first moments of unboxing and setup.
Oh, they are strict about it.
Very strict. They explicitly mandate a full 100% battery charge before you even think about touching the programming interface.
And there's a very good reason for that.
Which is?
Flash memory.
Okay.
It requires a very specific, totally stable voltage to write data correctly. When you're programming channel allocations or setting subaudible tones or saving those environmental profiles into the radio's EEPROM, which is the internal memory, the processor is actively writing code. If you try to do that on a depleted battery, or even just a battery fresh out of the box that only has, like, a surface charge.
Like when it says it's got 2 bars, but it really doesn't.
Exactly. The voltage can momentarily sag during a write cycle.
Oh, I see.
And that tiny brownout, it corrupts the save. You end up with a radio that acts erratically, drops channels, or just completely locks up in the field.
Because you essentially gave it a concussion while it was trying to learn.
That's exactly it. So establishing a baseline of maximum stable voltage is a structural requirement. It is not just a friendly suggestion from the manufacturer.
That makes a lot of sense.
Yeah.
I mean, you definitely don't want a firmware glitch when you are relying on the device for survival.
No, you do not.
Okay, so once we have that stable voltage and we've cleared out any factory test data, the user is immediately confronted with the Squelch dial.
The Squelch.
Right, and Squelch is a concept anyone who has touched a radio kind of knows, but the mechanics behind it are rarely understood. People usually just crank it until the static shuts up.
Right, they just spin the knob.
Yeah. But what is the actual mechanism happening inside the radio when I turn that Squelch knob?
Okay, so you are manually adjusting a voltage comparator inside the radio's receiver.
A voltage comparator.
Yes. See, the atmosphere is constantly boiling with background RF radiation, solar noise, electrical interference from power lines, atmospheric static.
It's just a sea of noise out there.
Exactly. That is your noise floor. So if the Squelch is completely open, the radio's amplifier is just endlessly pushing that chaotic noise floor into the speaker. Just shh.
Right.
When you turn the Squelch knob up, you are telling the internal circuitry, hey, do not send any audio to the speaker unless the incoming signal's voltage exceeds this specific threshold. You are literally building an electronic dam.
Okay, I love that. So is Squelch kind of like a bouncer at a really loud club?
Oh, bouncer.
Yeah, like the bouncer only opens the speaker when a VIP, which would be a strong, clear signal, arrives, and he keeps all the background noise out on the street.
Yes, that is exactly what it's doing.
But wait, if I'm stranded out in the woods or I'm trying to catch a distress call from a boat miles away, wouldn't I want the bouncer to just leave the door open?
You would think so.
Like, if I build that dam too high, aren't I risking blocking a weak, distant transmission that I desperately need to hear?
Well, in theory, you want it open, you want to hear everything. But in reality, human biology gets in the way.
Biology.
Yeah. Listening to raw, unsquelched atmospheric static at high volume for more than a few minutes causes profound auditory fatigue.
Oh, I guess that makes sense. It's exhausting.
It is. Your brain actually starts to tune it out. So if a faint, genuine human voice breaks through after 3 hours of you just listening to white noise, your brain often won't even register the pattern change.
Wow, you just become deaf to it.
You will miss the call entirely. So setting the Squelch to the exact threshold where the static just barely breaks the absolute minimum necessary to keep the speaker quiet, that keeps your ears fresh.
Ah.
It ensures that when a signal does come in, that sudden burst of audio immediately grabs your attention.
So it's about preserving your own situational awareness just as much as filtering the radio itself.
Exactly.
Okay, and right after that Squelch adjustment, the manual dictates something that honestly feels totally counterintuitive to me.
The power settings.
Yes. They want you to set the transmit power to a moderate level for your initial testing. Now, if I just dropped serious money on a 5-watt or 25-watt transmitter, my first instinct is to push it to absolute maximum power.
Of course.
I want to make sure I'm getting every ounce of range I paid for. So why am I intentionally throttling my own device right out of the gate?
Because pushing maximum transmit power immediately is a brilliant way to completely mask underlying inefficiencies in your physical setup.
Masking them.
Yeah. High power acts like a brute force band-aid.
Oh, I see.
If your antenna isn't mounted correctly or your cables are slightly degraded, pumping massive wattage through the system might still get your signal to the receiver, but you are doing it incredibly inefficiently.
So it works, but at a huge cost.
Right. You are burning through your battery reserves at an exponential rate. And even more importantly, you are likely distorting your audio.
Because of the heat.
Yes.
Yeah.
A radio running at 100% capacity generates a tremendous amount of heat. And that heat changes the resistance in the internal components, which can really muddy your voice.
Okay, so by starting at a moderate output, say like 1 watt or 2 watts, you are forcing the system to prove its efficiency.
Yes.
Like if you can get a crisp, clean microphone test to your partner at a moderate level, you know your hardware is actually dialed in.
Exactly the point. You verify the system's baseline health first. You save that maximum power setting for when the environment violently changes.
Like that storm rolling in.
Right, when atmospheric attenuation spikes and you suddenly really need that extra push.
Got it. Which perfectly transitions us to the absolute bottleneck of this entire operation. Because we can have a perfectly charged battery, meticulously dialed squelch, and a moderate power test, but none of it means anything if the actual antenna isn't processing the RF energy correctly.
It's all about the antenna.
And the guide dives deep into the physical reality of antennas, and it brings up SWR, standing wave ratio. And the physics happening here are just wild.
If we connect this to the bigger picture, SWR is the single most critical concept in radio operation.
Okay, break it down for us.
So when you press the transmit button, the radio's final stage transistors generate alternating current at a specific frequency. That electrical energy travels up the coaxial cable and into the antenna.
Okay, following so far.
The antenna's job is to act as a transducer. It takes that electrical energy and throws it out into the atmosphere as electromagnetic radiation.
Right.
But that transfer only happens efficiently if the physical length of the antenna perfectly resonates with the specific wavelength of the frequency you are transmitting on.
Wait, so the actual physical piece of metal has to mathematically match the invisible wave?
Down to the millimeter.
That is crazy.
Yeah. If the antenna is too long or too short for the frequency, the impedance doesn't match. The antenna simply cannot release all the energy being pushed into it. And where does it go?
Well, the laws of thermodynamics dictate that energy doesn't just disappear.
Right.
If the power can't exit the antenna, it reflects. It hits the mismatched impedance like a brick wall, turns around, and travels backward down the coaxial cable as a standing wave.
Oh.
Yeah, slamming directly back into your radio's sensitive internal components.
That is incredible. So it is, it's like hooking a fire hose up to a high-pressure hydrant, but leaving the nozzle closed.
Great visual. Yes.
You turn on the hydrant, the water rushes down the hose, hits the closed nozzle, and all that massive hydraulic pressure backlashes straight into the pump. So if your SWR is high, your own transmit power is literally cooking the inside of your radio.
It will catastrophically destroy the final output transistors. You will literally melt your own equipment.
Wow.
This is why tuning the physical antenna is not optional. It is mandatory.
Okay. And the guide stresses two main types of antennas for this, right? The steel whip and the digital antenna. All right, so a digital antenna, which has integrated circuitry to manage some of this tuning and reduce noise, is highly efficient. But the traditional steel whip is really praised for its ruggedness.
Yeah, you see those whipping around on Jeeps all the time.
Exactly. But to tune a steel whip, you have to use an SWR meter. That meter reads the ratio of forward power, which is energy leaving the antenna, versus reflected power, the energy bouncing back.
And the instructions for this tuning process are so incredibly specific. I mean, you can't just do it in your garage.
Oh, definitely not.
You have to take the vehicle or the boat out to a completely clear, open area. You have to ensure there are no metal buildings, other vehicles, or even large trees nearby.
Yes.
Why is the environment around the tuning process so sensitive? I mean, I'm just trying to measure a piece of wire on my car.
Because radio frequencies couple with conductive materials in their immediate vicinity.
Couple.
Yeah, they interact with them.
Yeah.
This is known as parasitic capacitance.
Parasitic capacitance. Okay.
If you try to tune your antenna while you're parked next to a metal garage door, the radio waves leaving your antenna will instantly interact with the metal door. That alters the electrical characteristics of the space around the antenna.
So the door becomes part of the antenna system.
Basically, yeah.
Right.
And the SWR meter will give you a false reading based on the garage door's reflection, not your antenna's actual resonance.
That is wild.
So you have to isolate the system in an open field. That way you are measuring only the pure interaction between the antenna and the open atmosphere.
Okay, so you drive out to an empty field, hook up the meter, key the mic, and check the reflection. And if it's high, you are physically loosening a set screw and sliding a steel rod up or down by tiny, tiny fractions of an inch until the needle on the meter drops.
That's the process.
It's just wild to me that in an era of programmable touchscreens and AI, optimizing the system still comes down to physically manipulating a metal rod by 2 millimeters.
Yeah, physics doesn't care about software.
Fair point.
Resonance is a geometric reality. Until that geometry is correct, your software is useless.
But once that physical bottleneck is cleared, right, once the SWR is as close to a 1-to-1 ratio as possible and the energy is flowing cleanly into the sky, the Yacht Supply 24 guide finally lets us dive into the software interface.
Yes, finally.
And this is where the Cobra system really opens up its capabilities, specifically regarding FRS integration and ham bands. Now, FRS being the family radio service, which shares space with GMRS but operates at much lower power for localized chatter.
Right. And the programming software allows you to build a highly organized communication matrix. You aren't just scanning 40 random channels anymore.
Right.
The setup involves diligently allocating specific memory slots. You designate channel 1 or a specific preset as your absolute starting point. This is usually a highly monitored emergency frequency.
Okay.
Then you scan for available ham options, assuming you have the proper licensing, of course.
Yeah.
And you weave those into the radio scan list.
Now, the guide also emphasizes setting up privacy codes for your personal channels. And I really want to clarify this because the terminology is incredibly misleading.
Very misleading.
Privacy code implies encryption. It sounds like if I turn on privacy code 12, my voice is scrambled and no one else in the woods can hear my conversation. That's fundamentally false, isn't it?
Completely false, and honestly a dangerous assumption in an emergency.
Wow. Oh.
A privacy code is technically known as CTCSS, or Continuous Tone-Coded Squelch System.
Continuous tone-coded squelch system.
Yeah, and it provides zero encryption.
Zero.
None. When you enable it, your radio simply injects a continuous subaudible tone underneath your voice transmission. It's a very low hum that human ears literally can't hear.
Yeah.
Your buddy's radio is programmed to keep its squelch completely closed unless it detects that specific subaudible tone.
Ah, okay. So anyone else on the channel who isn't using codes will hear every single word you say.
Every word.
Their radios will just open up and play your voice, but your radio will ignore them unless they transmit your specific secret hum.
Exactly.
So it's not about hiding your conversation. It's about hiding everyone else's conversation from you.
Yes.
It's basically an advanced noise filter, keeping your local channel clear of crosstalk.
Precisely. It allows multiple groups to share a busy frequency, like, say, a GMRS channel at a crowded ski resort, without constantly hearing each other's chatter.
That makes total sense.
And the Cobra software lets you bind these codes to specific channels, label them alphanumerically on the display, and run priority scanning.
Oh, nice.
So your radio can silently listen for your buddy's subaudible tone on channel 4, while simultaneously checking channel 16 for marine emergencies every 2 seconds in the background.
Here's where it gets really interesting, though. The software allows you to build completely distinct environmental profiles. You can save an urban profile and a rural profile. And this circles back to our earlier discussion about power, because if I'm in a dense urban environment surrounded by concrete, steel, and interference, my instinct is to crank the transmitter to 100% to punch through the walls.
Naturally.
But the guide says the exact opposite. The urban profile demands low power and highly aggressive noise filters. Why wouldn't I use maximum force against concrete?
Because of multi-path interference.
Multi-path interference. What is that?
When you blast maximum RF power in a city, the radio waves hit the steel and concrete buildings and violently bounce in 1,000 different directions.
Like an echo chamber.
Exactly. Those reflected waves all eventually reach the receiving radio, but because they took slightly different paths, bouncing off different skyscrapers, they arrive milliseconds apart.
Oh, I see.
They crash into each other, phase canceling and completely distorting the signal. Your voice turns into an unrecognizable robotic garble.
Oh, man. So it ruins the transmission.
Totally ruins it. By dropping to low power in an urban profile, you severely limit those reflections. The signal doesn't bounce as far, but the direct, clean path has a much better chance of arriving intact.
Wow. So brute force actually destroys the data in a city.
Yes.
But if you load the rural profile or the open water marine profile...
Then the physics change again.
Right.
On open water, you have pure line of sight. There are no buildings to cause multi-path reflections. The rural profile unlocks wideband transmission and allows the radio to push much higher wattage because the environment can actually handle the energy.
The wave can just travel uninhibited straight to the horizon.
Exactly. You are manipulating the internal software to perfectly map onto the physical reality of the topology.
It is a constant negotiation with nature.
It really is.
But, you know, even with perfect SWR, brilliant environmental profiles, and fully charged batteries, the guide spends a massive amount of time on the gritty reality of field deployment.
Troubleshooting and long-term maintenance.
Yeah, because when a radio fails out there, it's almost never a software glitch, right? It's the physical world taking its toll.
The environment is actively trying to destroy the hardware from the moment you take it outside.
It really wants it dead.
Oh, absolutely.
Right.
And the troubleshooting steps they outline prove this. If you are off-roading and your signal suddenly drops to 0, you don't pull out a laptop and check your EEPROM setting.
Right, you walk around to the back of the Jeep and check the physical geometry of the steel whip.
Yes, because if a low-hanging branch caught the antenna and put a 2-inch kink in the metal hip.
Then the electrical length of the antenna has just been altered.
Exactly.
Yeah.
It is no longer resonant with your frequency. Your SWR has skyrocketed, the energy is reflecting back into the radio, and the system is literally shutting itself down to prevent a fire.
So you have to fix the geometry.
You have to fix the geometry. You have to check if a new metal roof rack is suddenly causing parasitic capacitance. In marine setups, you have to trace the entire coaxial cable for microscopic breaks in the shielding that might be letting in ambient engine noise.
The maintenance schedule is equally brutal. They demand you keep the unit dry, even if it has a high waterproof rating.
Yes.
But the one that really caught my eye was the mandate to wipe the battery contacts with a clean, dry cloth every single month, regardless of whether they look dirty or not. Why such an obsessive focus on a couple of metal prongs?
It comes back to the physics of power draw.
Okay.
When you hit the transmit button on a high-power radio, the sudden amp draw from the battery is massive. It's a huge surge. In a marine environment, or even just a humid climate, microscopic galvanic corrosion forms on those metal battery contacts.
Galvanic corrosion.
Yeah, it might be entirely invisible to the naked eye, just a molecule-thin layer of oxidation.
Wow.
But that oxidation creates electrical resistance.
Oh, I see where this is going. So when the radio suddenly asks for a massive surge of power to push a 25-watt signal,
The resistance at the contacts causes a severe voltage drop.
Uh.
The radio's processor detects the voltage plummeting, assumes the battery is entirely dead, and completely shuts the transmission down.
oh man, so you have a totally full battery and a perfectly tuned radio, but a microscopic layer of salt air on a contact point has just silenced you.
To shut you down completely.
Right.
Wiping those contacts monthly breaks down that oxidation layer. Similarly, inspecting the housing of digital antennas is vital.
Because of the salt.
Right. If salt air penetrates the seals, it degrades the internal tuning circuits, destroying your SWR from the inside out.
It just requires a level of discipline that we simply aren't used to with consumer electronics. I mean, we are used to things just working until they die, and then we just replace them.
Yeah, but in the context, these radios are used in, coordinating a mountain rescue, tracking weather fronts off the coast. Managing heavy machinery maintenance isn't about protecting an investment.
Right.
It's about ensuring the physical bridge between you and the rest of the world remains intact. You are fighting entropy on a monthly basis.
So what does this all mean? We started this deep dive talking about the sheer frustration of hitting the talk button and hearing nothing but static. We assumed a premium Cobra radio was just a magical box.
Right.
But what this Yacht Supply 24 material reveals is that effective communication is an incredibly deliberate, highly intentional dance. It is a constant, rigorous calibration between the internal software parameters you set and the brutal, unforgiving physics of the physical space you occupy.
You really cannot ignore the hardware to focus on the software.
Right, and you cannot rely on an aggressive software profile to fix an untuned, mismatched antenna.
Absolutely. And, this raises an important question, and it brings me right back to that concept of the standing wave ratio.
Oh, okay.
We spent this entire deep dive analyzing how a radio system demands incredibly precise physical alignment to ensure its energy is actually transmitted outward rather than destructively reflected back onto its own internal components.
Or the fire hose analogy.
Exactly. If the system isn't tuned to the reality of its surroundings, the power just violently bounces back and burns the core out.
Yeah.
It makes you wonder, how might that raw physical principle serve as a mirror for human communication?
Oh, wow.
When we step into a new environment, a new job, a tense relationship, a foreign culture, and we just start broadcasting our own assumptions at maximum volume without ever tuning into the reality of the room.
Wow, yeah.
How much of our own energy just destructively bounces back at us, leaving us entirely unheard?